It's really nice to be back. I was here just last year. So that's great. And I think I already had lots of really interesting conversations with some of you. So yeah. I want to talk about some of the work that I've been doing in the past year that focuses on language technology, specifically large language models, and how it connects to social sciences and specifically survey methodology. And you might be thinking that these are two areas that are perhaps not the most closely linked, but hopefully at the end of the talk you might think that there are more connections than you previously thought. Are some of you survey methodologists? Kind of. Okay, I know some of you have done surveys. Okay, so then I'm going to start with some definitions, which is probably stuff that you know already, but just to kind of set the stage. So NLP is supposed to be this area or subfield of computer science that just allows computers to understand and communicate with human language, right? Surveys are not exactly the bread and butter of the typical NLP researcher. They do them sometimes. And maybe we think about survey design principles for designing annotation interfaces. For example, if you want to create training data for machine learning or NLP methods, but it's not really something that we work with a lot, right? Or you could have user surveys, which you field to understand what people think about a NLP or a language technology system to like get their feedback and user experience. And on the other hand, survey methodology is concerned with the study of errors in surveys, right? And how to make surveys as accurate as possible. And again, NLP methods are not fundamental in survey methodology. Sometimes people do automatic translation of survey questions, or they might use text mining methods to analyze free text data, right? But I think these areas are inching closer. And so here I'm put the titles of two papers that came out last year. The first one was talking about the opportunities of large language models in survey research, like how LLMs can be integrated into different parts of the survey pipeline. And then this other paper, which looks at it from the opposite point of view about how survey methodology can help us design better training data to improve these models in different types of ways. So we wrote a perspective paper recently where we tried to see these intersections more closely and try and understand how each field can benefit each other, given the new developments in NLP specifically. And so this kind of forms the basis of this talk, and I'll talk about each of these sides one by one. So what survey methodology can do for NLP and what NLP can do for survey methodology. And I won't talk about all of these different aspects where each field can help the other, but focus on two of these. The first one is about how we can use survey questions that have been developed for people for evaluating or measuring social constructs or attitudes in people, and using that to evaluate LLMs, which is something that people are doing more and more these days. And then a rather emergent area that people have been exploring, which is to use large language models to simulate human survey respondents. So let's start with this part of the pipeline first, what survey methodology can do for NLP, right? So I already mentioned that we can have evaluation of NLP systems through surveys, but one big area nowadays is reusing surveys of humans to serve as a benchmark for LLMs, right? So there's all of this work on LLM alignment to see which type of people they are closest to. And to do that, people use these public opinion surveys about people, like, for example, what do people think about controversial topics like abortion or smoking bans, and see which groups of people LLM's answers closely match with. The topic that I want to talk about is this one, though, which is not to use survey responses, but survey questions or items directly. And here we want to see if we can use surveys that have been designed for people to measure political values in them, and see if we can reuse them to find or measure political values in large language models. So biased LLMs are harmful. They can sway people in certain ways. So this paper by Yakesh and colleagues showed that if you wrote or co-wrote stuff with biased LLMs, especially politically biased or opinionated LLMs, they shift the opinions of the person who's doing the co-writing with them, right? And so maybe some of you saw these title or these newspaper articles that came out very soon after ChatGPT was released, that was sort of saying that LLMs, especially ChatGPT, has a strong liberal bias, right? And this caused a bit of backlash where some people who were not liberal felt that these technologies were not representing them. So how do we measure political leaning in LLMs? So there's some recent papers that use voting advice applications. I know some of you are also working with voting advice applications. And then there are also some papers that use real LLM user interactions. But the predominant method when we looked at different papers checking or measuring political leaning of LLMs was based on survey questionnaires, right? So the idea would be to ask an LLM a question like this. Do you agree or disagree with this statement? And the most widely used survey over here is something called the political compass test, and I'll come back to that in a bit. But the other choice or design choice here was to ask the LLM to choose one option instead of giving a free text answer, right? As we would ask people to often answer questions like this. Okay, so the political compass test. Do some of you know about it? Have any of you taken it?
I have played with it, and one funny thing about it is there are many filter questions that don't mean anything, but it's not explaining and people don't seem to hear.
Okay, I think my views align with yours. But yeah, so the political compass test is a bit of an internet quiz or something that you might find on BuzzFeed. Like these BuzzFeed quizzes that were like, yeah, based on your interest, this is the city you should live in. So basically not very scientific, right? We don't really know who designed this survey or like what principles they were based on. And so this is one example where political scientists tried to place different public figures and politicians on the political compass. So this is what the political compass looks like, that it's a sort of two-dimensional space of left and right, and then you have libertarian and authoritarian, right? And then you have these four quadrants where you place a person based on their views or their answers to the political compass test. And so here we can see Donald Trump. So he's on the right quadrant and like quite high up. So probably that makes sense. But then Hillary Clinton is on the right of him. And that's a bit strange, right? I'm not a political scientist, but this seems a bit off, right? And then we are basically using this technique as the de facto measurement tool for LLM bias. So can we do better? That's what we tried to figure out in this paper that we did with David Garcia, whom Ingmar mentioned, with a master's student in his master's thesis. And we tried to use the World Values Survey. So the World Value Survey is a validated measurement inventory that has been around for quite some time, decades in fact. It has many different types of dimensions, not just politics, but we picked the politics related ones. And then we also looked at the free text answers of LLMs, right? Because the idea is that this is supposed to be much more realistic. Like when lay users are interacting with LLMs, they're not forcing them to pick 1 out of 4 options. These LLMs are supposed to be dialogue-based and conversational agents. And so probably these interactions will also be based on free text. And the experimental setup consists of something like this, where we have these propositions which are taken from the World Values Survey as well as the political compass test. So this is one example of a proposition, and you can basically place whether someone agrees or disagrees with this proposition in this left-right dimension or the cultural and economic dimension. This is something that we did manually. And then we take these propositions from these 2 different sources, the political compass test and the World Values Surveys. And then we do reformulations of each proposition. So the reason for that is these survey questions might just be already in the training data of these LLMs. They could have just memorized them. And so we also want to see if or if different variants lead to different answers or not. And then we take 7 instruction-tuned large language models, so models that follow instructions and don't just do sentence completion. And we run the same prompt with the same proposition 3 times for each LLM. And furthermore, another big problem with these LLMs is that they are brittle, right? That you make one small change to the prompt and their behavior totally changes. So this was the baseline that we opted for. So whether the LLM agreed or disagreed with the proposition, but then we also tried other ways of asking this question, right? Which were kind of sourced from existing literature on prompt variations. And so I've highlighted the ones that will be important later on, but we kind of tried as many variations as we could. And how do we now convert these free text responses to a quantitative signal, right? Before, that was the advantage of this forced question answering mode, right? You could just get that answer and get the sort of stance of the LLM automatically. So with free text, we have to do one extra step where we now build a customized stance classifier. So we take this model, BART, which is an encoder-based model. So not like ChatGPT or these generative LLMs, but very useful for classification tasks. So like a cousin of BERT. And we fine-tune this model on some of our data, right? We take the proposition, the LLM answer, and then the manually annotated labels, yes, neutral, or no. And we fine-tune the model on this data so that we can get the model's stance on that proposition. And then we also left out a portion of this manually annotated data so that we can validate our customized classifier, and we saw that it was pretty good. And it seemed to be quite reliable and have low uncertainty for the instruction-tuned models, so we used it to annotate the rest of our data. So that's how we convert this free text into a quantitative signal. And so now I'll show you the results that we see. So I told you that we have basically these 4 quadrants, right? So left, right, and then this economic and cultural dimensions. And so we have 2 types of measurements, one from the World Value Survey. So these are the filled markers, and the unfilled markers are supposed to be the scores from the political compass test. And so first, let's see what the political compass test gives us. When we look at these 7 models, we do indeed see that they are all in this left lower quadrant, which would say that they have left-leaning bias, and they're also more positive about cultural issues and less about economic issues. And here, at least, like this purple box is GPT 3.5, right, which was this original ChatGPT model. And indeed, if you use a measurement like this, you would conclude that this is a very left-leaning model. Now let's see what happens when we use the world values. So I can tell you that some of these models, their position does not change, right? So Falcon 40 billion, Llama 7 billion, and GPT-4, they kind of stay in the same position as they were, irrespective of which measurement we use. So that's why I've removed them from the graph. But the rest, they do shift. So for example, ChatGPT or GPT 3.5, so that's now this purple filled box, it has moved both rightwards and upwards, right? And again, I'm not claiming that these models have now shifted to the right. They are still left-leaning, but at least it seems that the political compass test exaggerates this left-leaning tendency, right? And so we should probably think a little bit more about the measurement instruments that we use when we talk about political bias in these LLMs. And in terms of the consistency of these political bias in the face of these prompt variations, we do see a little bit more left-leaning tendencies for some prompt variations, and the only time we get any right-leaning behavior is when we use these two prompt variations. But more or less, models that are somewhere around the center or not too far from the center, they also stay towards the center even when we have prompt variations. So what are the takeaways from this exercise? We know that LLMs are being widely used in social settings and social applications, right? And so in that sense, evaluating them is a social measurement problem. And here, the measurement instrument we use is quite important, and survey methodology can be quite helpful here, because survey data or survey instruments were designed to think about theoretical relationships between latent factors, right? And so if we use good surveys, we can have less ad hoc evaluations. But we should also keep in mind that not all surveys are designed equal, right? And one other issue, which was this provocation thing that I hinted about in the title, was that do survey-based measurements actually tell us about the real-life behavior of LLMs? So that's maybe a question to think about. But I also want to say that our paper, this is from ACL this year, and the code and data set is available if some of you are interested in working with these propositions and the reformulation. So feel free to check it out. Okay, I want to move on to the next part about what survey methodology, or rather what NLP can do for survey methodology now. So these are a few examples where we are seeing more and more work in improving surveys with LLMs or AI. So one rather interesting topic is these AI-led interviews. The idea is that qualitative interviews can give us a lot of rich, deep data, but they take a lot of time, right, as opposed to a quantitative survey. And so can we scale up some of these qualitative interviews with an AI-led interviewer, right? So that's kind of the idea that some people are exploring now. So analyzing free text responses, I already mentioned this. Survey design, I think some of you also have work on this about translating survey items using NLP techniques to also do cross-cultural translation. So that's also falling under this area. The one that I want to take a deeper dive into, though, is simulating survey responses. So maybe some of you know about this paper. It was quite influential. It came out like 2 years ago, and Lisa Argyle, who is the lead author, she also gave a keynote at IC2S2 this year talking about this idea of silicon samples, where the broad goal is to reuse LLMs and give them personas or steer them to take on the roles of survey respondents, right? So one example of that would be that I can steer the LLM by saying that how would somebody of this demographic vote in a particular election, right? And this can maybe give us ways of doing surveys in a more cheap manner, or more conservatively help us pre-test surveys, right? And this is now outside just the research realm. So there are also products that have come out that support this type of silicon samples. So one example is Expected Parrot, where you can do experiments with AI agents. I should also say that these are not just survey experiments, right? Like these could also be behavioral experiments. One other big topic is social media simulation. So they all kind of borrow from this idea of social silicon samples. But one big question here is that do LLMs actually represent the people that they're supposed to be simulating? Do we know that? So there seems to be a bit of like mixed evidence about this. So again, this is the paper from Lisa Argyle and colleagues that say that some LLMs, even they in fact tried it with GPT-3, they said that these models do seem to have some degree of algorithmic fidelity, right? That allows them to simulate different groups of people. So this was a paper that came out afterwards. This was not for surveys, but using these silicon samples for data annotation, particularly data annotation of subjective content like hate speech or offensive language. And this paper said that it was kind of mixed. For some types of tasks, it seemed to work, for others, not so much. And then there are papers like this by Angelina Wang and colleagues that outright say that LLMs harmfully misportray people, right? That they don't seem to represent people at all. So at least anecdotally, it seems to be there are some conflicting findings. And if we want to improve the representativeness of these models, we first need to measure it, right? So we wanted to see how that's done. So what we did was a literature review of whether LLMs are demographically representative or not. So we looked at papers that mention either demographics or LLMs, and we tried to use different search engines to cover different disciplines, and we wanted to see if the current community of researchers who are working on LLMs for social applications agree on whether LLMs are representative or not. So what does it even mean for an LLM to be representative? Maybe that's the first question. So representativeness, like words like fairness or bias, are often called suitcase words. So these are words that pack together a lot of colloquial appeal, but these need to be unpacked depending on the specific context, right? So you can contrast this with a word like multicollinearity, which has a very concrete definition, whereas for representativeness, probably all of us have something in our minds about when I say representative, but we need to be explicit and verbalize it so that we know that we're on the same page. So when it comes to LLMs, we found two broad types of representativeness. One I've already mentioned is this sort of like simulation, or what we were calling impersonation, or some people call it role play, about whether LLMs can take on a particular role or not. But then there's also this personalization use case, which goes beyond simulation, right? Which is whether an LLM actually works for different groups of people or not. So if like I have the same persona and I ask a question, does it actually give me useful advice? Does it adapt to my needs or not? And then sometimes you can not give a persona at all, and then you would be testing for the default values or representativeness of the LLM. So when we looked at these papers, we tried to see different things. We were, of course, mainly interested in which demographic groups are studied, but we also looked at things like models and the populations. And so in terms of the demographic category, we see that there's a lot of research on gender, race, and age, but not as much on, say, things like sexuality, disability, and immigration. We also found that people often don't even explicitly define a target population, but they sometimes use descriptors like Republicans or Democrats that hint towards this being a US context. And then we also see that people mainly focus on using closed source LLMs, right? So 80% of the papers were using at least one OpenAI model. And one really important thing is how these demographic factors are defined and operationalized, right? So here again, I have the paper from Lisa Argyle and colleagues, which were prompting the LLMs with this type of prompt, right, to make it role play. And then this is an example from a paper by Myra Cheng and colleagues. And so what you can see here is that they're using the same type of demographic groups. So here, young, and here 20-year-old person, so they're both interested in age, but they're using very different descriptors for it, right? And the same for gender, man versus male. So why are we interested in this? Because again, LLMs are brittle, right? And we don't really know what the impacts of using male versus man can have. And there's also quite a bit of it's also quite ad hoc how we do this type of prompting. And then the big question was the conclusion on representativeness, like whether the papers say that the LLMs are representative or not. So I already mentioned the paper by Lisa Argyle and colleagues, and here they say that yes, some LLMs seem to have algorithmic fidelity. And then there was this paper by Angelina Wang and colleagues, right, that just said no. And so we expected that this would be maybe a bit clear-cut, that only a minority of papers would be saying yes. But as it turned out, at least almost 30% of the papers seemed to say yes, and then another 30% of the papers said no, right? So there also seems to be a bit of like division on the conclusions here. And so finally, we tried to see why the papers were coming up with different conclusions. So we looked at some factors. Again, I should say that this is very much not a sort of controlled setup, right? We saw that many of these papers have very different ways of prompting. But so we tried to see a few broad factors. So one thing we saw was that when people use fine-tuning to steer LLMs, they were more likely to say that LLMs are representative, which makes sense. So maybe the base LLMs are not very good, but if you give them a little bit more data about the specific population that you're interested in, maybe that improves results, right? However, there are other issues here. So one big problem is how these papers report their results. When we want to say that an LLM is representative, we want to know for which groups, right? And so therefore, we would like to see the results for different groups that are included. So this is what we mean by demographically disaggregated analysis. And so here we have a graph where we see the number of papers that say yes, whereas the number of papers that say no. And what we see here is that in the papers that say yes, around 30% don't do any type of demographically disaggregated analysis, right? So how do we know that these LLMs work equally well for different groups if we don't have this result? They instead give us some type of overall LLM performance. The other thing is that we also saw that papers that tend to say yes, they have the lowest proportion of including non-binary gender categories, right? So they usually use only male, female categories. Although I will say that in general, only like a fifth of the papers use non-binary gender categories at all, right? So this is bad across the spectrum, but at least when papers do, they tend to say partial more. And we see similar results for marginalized racial categories as well. So just to conclude this part, I'd like to mention that this is pretty vital, right, for something like representativeness. And this goes beyond demographic groups. Any type of groups that we're interested in, we should show results disaggregated. And here, I think the social sciences can again be quite useful, particularly survey methodology, because they've been thinking about representativeness for a really long time, about running representative surveys, and also thinking about marginalized groups and hard to reach groups, right? So we can turn to them for defining and operationalizing some of these concepts. So this paper, that it was also at ACL this year, and we have these annotated data set of papers available. So we didn't just annotate the things that I showed, but we also looked at response formats, the exact LLMs used. So if you're interested in the data set, I think it's pretty extensive, and you could do some more analysis on this. So feel free to check that out as well. Okay, and then wrapping up, right? I do think that there are quite a few synergies between NLP and survey methodology, particularly when it comes to measurement of marginalized groups. And this is not just interesting for simulations, but also for thinking about AI safety or biases and harms, right? And here we can learn a lot from the social sciences and survey methodology. But we need more exchange to realize this, right? Because we have surveys like BuzzFeed questions or the political compass test that seems to exist. But that doesn't mean that these are high quality surveys, right? And so we need to actually talk to people who are running these surveys to understand what even a high quality survey means. And then there are also further questions. For example, as I said, do LLM answers to survey questions actually match their behavior? What do lay users think of silicon sampling, right? Like, do they think it's okay to have their voices replaced? Maybe for some types of tasks, it might be. For others, not. But this is something that we might need to find out. I just want to mention that some of the follow-ups that we're doing is looking at the impact of LLM's political biases when we use them for political annotation tasks, and also looking at perceptions of AI safety and bias, right, to try and see how different groups of people think about their experiences with these models. Okay. I'd like to end by thanking all of the fantastic collaborators who worked with me on these projects, and thanks to you all for listening as well.